Domain and range from graphs. So domain, we've kind of talked about this before, but let's review. Domain describes all the possible independent values. Now, this usually uses the letter X, but not always. And we also like to think of these as inputs. Okay? Range describes all the possible dependent values. And this uses the letter Y. Normally, if it's a real world, it might not. And then we like to consider these outputs. So there's a couple kinds of domain and range. The first we have to talk about is discrete graphs. We talked a little bit about this the other day. Discrete is when you have basically a scatter plot. Okay, so with discrete domain and range, you write it with a list of numbers from the least to the greatest. So smallest to largest, that's the way this list is ordered out. Okay, domain, we work from left to right. And range, we work from bottom to top. Because on range, the Y values, the smallest are at the bottom. And for domain, the X values, the smallest are at the left. Okay, so I'm going to use two different colors. The entire time, I'm going to always make my domain blue, and I'm always going to make my range red. So for the first example, we want to find domain, so I want all of my X's. Since these are not connected, we just have to basically find the X values of all of these points. So I'm going to start at the furthest left point, and this guy's X value is 1, 2, 3, 4, -5. So we're going to use these little curly braces that says, hey, this is the set of numbers that fits my domain. And we're going to start listing -5. Then the next one would be this point at -2. I don't care about the Y's right now. All I want are the X values. This is at 0. This X value is at a 1. This guy's X value is 2, 3, 4. And this guy's X value is 6. So with domain, all we want are the X values. We don't really care about any of the other numbers. So this is all of the numbers that are in my domain. -5, -2, 0, 1, 4, and 6. If there's not a number listed here, then it doesn't exist in the domain. So for example, I see that 2 is not listed. And if I look at where X is 2, all along this X equals 2, there's not a point there, which is why that's not in the domain. Okay. Now let's do the same thing for range. So range is my Y, so we're going to work the bottom, the lowest point to the highest point. So I see that this is my lowest point. So this guy's Y value is -1, 2, 3, 4. This is -5 again. They're not always the same. Then this is my next point at -2. This is my next highest point at -1. This is my next highest point at a Y of 0. Now look, these actually both have a Y of 0. You only need to list it once. If there's something that's repeating, you don't need to list it twice. And then this guy has a Y value of 1, 2, 3, 4, 5. So this actually has one less value than the domain because my 0 is technically twice. So again, if there's not a number here in this range, that means there's not a Y value possible. So if I take 4, for example, 4 is right here at the Y value. There is no point along this line. No height of 4 gives me a coordinate point. So that's not in the range. Okay, let's do one more. So for example 2, again, we're going to find domain. So I want all the X values from left to right. So my leftmost point is this guy. So that guy's X is a 1. So curly brace 1. My next point is a 2. I don't care about the Y values because we're talking about domain right now. 3, 4, an X value of 5, and an X value of 6. Notice how we're going towards the X axis, not the Y axis. We want the X values, not the Y's. Now when we talk about range, we're going to work bottom to top. So that would be this point here, and now I want the Y value, so I'm going to go towards the Y axis. So I have -1. This is the next point at 0. Then this point here at 1. This point here at 2, we want the y values, not the x's. We're doing range now. And then this final one at 6. So domain only cares about possible x values. Range only cares about possible y values. If it's a scatter plot, then we're just listing out all the x coordinates and all the y coordinates separately. Okay. Now let's talk about continuous. This is mostly what you're going to see. It's mostly continuous graphs. So with continuous graphs, domain and range are written with inequalities. And they're again written from least to greatest. We always like to do least to greatest. Lowest to highest. Okay, so this is how it's going to look. Something kind of like this. If it's domain, you're going to use an X. If it's range, that guy's going to change to a Y. So this is that compound inequality we talked about a couple weeks ago. So the smallest number, and then you're going to pick a symbol. Well, the symbols depend on what the points are. You're going to use an open circle for less than, or you're going to use a closed circle for less than or equal to, just like we did before. Okay, then your variable goes in the middle because we're lowest to highest, so smallest number, then all of my possibilities, then my highest number. Okay, so let's do an example to see what this looks like. So domains are my x's, so let's look at example 3. I want the furthest left point on this graph, and I know that that's here. Now, since it's domain, I don't want the y, I want x. So here is my, and look, it's closed and closed. Now the furthest right point is this point up at the top here. So we're going to kind of follow that guy down to the x-axis, and I'm going to make him an open circle because that's what he is right here. And you see how this line is everything in between? So I'm going to kind of shade everything in between here. I'm going to shade all that stuff. We can do this. We've done this before. So we're going to write this inequality. -2, -1, -2. That's my lowest. So -2. Because it's a closed circle, I'm going to have less than or equal to. All of your x's are in the middle here. So I'm going to put x. And then on the furthest to the right, I have 4. And it's an open circle, so I'm going to say less than 4. The reason why we can't list everything. Let's just take the numbers between 1 and 2, for example. Half is not the only number in between that. Or sorry, let's do 0 and 1. Half is not the only number between 0 and 1. A quarter, an eighth, a 16th, a 32nd, a 64th. You can infinitely divide 0 and 1 into as many decimals and fractions as you can. This goes on forever. So we can't sit here and actually plot all these points and list them out like we did earlier. So we use an inequality to catch all of the little decimals and fractions I may not remember to think of. So that's why we use the inequalities with continuous graphs, not with discrete. Now let's look at the range. Range is going to work bottom to top, bottom to top. So my lowest value is here. So I'm going to kind of follow this to the y-axis now because I'm talking about range. And it's a solid circle. And now I need my highest point, which is this one up here. And I'm going to follow that guy to the y-axis as well because, again, I want range. And this is an open point. And I'm going to shade everything in between because that's where my line is. My line is in between those 2 points. And now I'm going to write the inequality for this. So this is your low point. This is your high point. So make sure you're not going backwards, smallest to largest. So we have -3. Because this is a solid point at -3, we're going to use less than or equal to. Now, this is range, so our variable changes to a y. That's the only difference between these two. And then the high value is at 3, and it's an open circle, so it's going to be less than. And you have just written all of the possible values of x and all the possible values for y for whatever function equation this is. Let's try another one. Let's look at 4. So we talk about domain again. We want left to right. So my furthest left point is this open circle here. That's my furthest left point. So I'm going to follow him down towards the x-axis because I'm talking about domain. And I'm going to put an open circle on -2. Then my furthest right point, if I follow this graph all the way to the right, I stop here. And that's a solid point. So I'm going to drop that solid point down to the x-axis and shade everything in between. So let's write this compound inequality. -2 is your lowest. It's an open circle, so it's a less than. If you want me to put that here. Then we have x is in the middle because it's domain, and that's the variable we use for domain. And then our highest value is a 1, and there's a solid circle, so it's going to be a less than or equal to 1. So this means that whatever function this is, I can have any x value as long as it's between -2 and 1. That's what that means. Now for the range, these are our outputs. So we're doing bottom to top. So our lowest point is not this circle here. This point is not the lowest anymore. You see how there's this curve underneath it? So my lowest point is actually sitting here on the axis. That's my lowest point. Because it's a solid line, we're going to use a solid point. So open circles are kind of like dashed lines. Solid circles are like solid lines. So those go back and forth, okay? Now, this is the lowest point. My highest point is still that open circle up here at 4. And here's my range, everything in between. So just like we did domain, we're going to write this guy from smallest to largest. So then the bottommost point first. So 0, then it's a solid point, so I need less than or equal to. Then y, because we're talking about range. And then the highest point is 4. And because he's an open circle, we're going to use less than. Okay? Let's talk about some things with arrows. So now that I have a dot on one side and an arrow on the other. So let's try this guy out. So again, I'm going to keep my domain in blue. Okay? So furthest left point is this guy here. That's my furthest left point. So I'm going to drop him down to the x-axis because that's what we're talking about. We're talking about domain. Now let's talk about the furthest right point. If I follow this line to the right, 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 I hit an arrow here. Well, guys, arrows usually mean this goes on forever. So what this is saying is this is going to keep going to the right forever and ever and ever. So when you shade, you're going to shade all the way across your axis and put an arrow on the end of it. You're never going to stop moving to the right. So that's why there's an arrow here. Since we're never stop moving to the right, that means we're going to go all the way to infinity. And it's a positive infinity because these are positive numbers over here. If it had been left, it would have been negative infinity. So now let's write this guy. So lowest number first. So this would be that -2. -2. Because it's an open circle, he's just plain less than. Then an x. Now, infinity, let's think about that for a second. Can you actually take this infinity, plug it into, let's say, y equals x, and get a value? No. This is just a symbol that represents the largest number possible. So we can't actually hold infinity, so it's going to be a less than symbol. So open circles, infinities, dashed lines are all less thans. Open circles, infinities, dashed lines are all less thans. Okay? This is kind of weird, but I don't really need this infinity part. So we're going to kind of ignore that for a minute. All you really have is -2 is less than x. So let's think about what this really means. I can have all the values of x. If I compare my shade to where this -2 is, all of these numbers are greater than -2. This is a more simplified way to say the domain. You took what was left and flipped it over. Don't need the infinity side. Take what's left and flip over the whole inequality. Now let's look at range. Let's try this guy. So where's the lowest point? So this one's always kind of weird. The lowest point, if I follow this guy, I hit my arrow again. So not only is this arrow moving to the right, he's also saying that this is moving down forever as well. So this is going to be forever this way. which means it's a negative numbers, so that would be negative infinity because they're negative numbers. Now, where's the highest point? Well, that's this point here, and we're going to call that about 6. We're going to kind of round just a little bit for this example. So this is what my range is. Negative 6 is the highest. Negative infinity is the smallest number I'm going to hit. So the smallest is negative infinity, but we're going to use a less than because we can't actually hit infinity. Then y, because we're talking about range. And the highest it goes is 6. And because this is an open circle, we're going to use a less than. Now, similarly to the domain, I don't need this infinity side, but this is already in the right order. Y is already on the left. So your simplified version is y's are smaller than 6. And make sure that makes sense. Look at your shade. If I pick 2, 2 is smaller than 6, so that makes this correct. Let's try another one. Pause the video, see if you can try to get this example 6 on your own. Okay, so for a domain, that's our x's. So we want furthest left to furthest right. So if I look at my graph, the furthest left I go is this arrow down here. He's moving to the left forever and ever and ever. Slowly, but he's moving to the left forever. These are negative numbers over here. So since I'm left forever, that's negative infinity. So we're going this way forever and ever and ever, negative infinity. And then where's the furthest right? Well, that would be this point here. So we're going to drop that guy to the x-axis, just like normal. And we're going to shade in our solution. So this is our domain, this blue shade right here. So the way we write this is we have negative infinity, because that's the lowest value possible. Less than, because you can't actually touch infinity. X, because we're talking about domain. Then the highest value is 1. Because he's a solid circle, we're going to use less than or equal to. And then I put a 1. Again, infinity sides don't really mean much, so we're going to simplify this down. X is already on the left if I kind of get rid of all this over here. X is on the left already. So we have x less than or equal to 1. And again, make sure that actually works. Pick a number in the blue shade, negative 2. Negative 2 is less than 1, so this is good. Double check. Range is y's, so same idea. So furthest bottom, so that would be the lowest, so down here. This is pointing down forever and ever. So down is the lowest I can go. So that's a negative infinity because you're going negatively on the y's. Then my highest point, be careful, it's not this guy. This curve is the highest point this graph goes. He's kind of in the middle somewhere. So this curve is actually where my range stops, is right here. That's where my range actually stops. So if we shade all of that, we can write our compound inequality. So the lowest number I have is negative infinity. That's the lowest number. Less than, because it's an infinity, don't do an equal to. Why? Because we're talking about range. And then the 2, it's a solid line on the y value of 2, so that means it's going to be less than or equal to 2. Because we have an infinity here, we can kind of ignore this. And this says that y's are always less than or equal to 2. We can check and make sure. If I choose negative 5 is smaller than 2, so that works. Let's look at 7. So 7 has arrows on both ends. So let's see kind of what happens here. So if I talk about domain, that's my x's, I want to go furthest left to furthest right. Well, the furthest left is, well, infinity, because he's going to go left forever and ever. Okay, that's fine. Negative infinity, we can handle that. But let's go to the right. If I move to the right, move to the right, move to the right, I hit another arrow. Okay, so that means this is going right forever and ever and ever. So positive infinity, because these are positive numbers over here. Well, if I shade this, you're shading the entire x-axis. All of those numbers are possibilities, from the smallest possible number to the largest possible number. We can write this 2 ways. We can write this as negative infinity less than x less than infinity, or a simpler way to say it is all real numbers. all the numbers that you can think of between the smallest one and the highest one are values for whatever function this is. There is a symbol we use, it's called a double barred R, and that's the symbol for all real numbers. Okay, so when you have infinities on both ends, this is what you actually have for the domain or the range. That's possible too. So now let's try range, bottom to top. So my lowest number, well, that's not going to come from here because that guy is going up, which is still useful, but that's not our lowest number. Our lowest number is from this guy because he's moving down. So I'm going down, negative infinity, forever and ever. I'm moving up forever and ever. So again, I'm shading the entire y-axis. Okay, well, if I'm shading the entire y-axis, it's kind of similar to the domain. My smallest y value is negative infinity, less than y, less than positive infinity. So even the range is all real numbers. So sometimes there is not any values that are restricted. You can use the double barred R here too. I can have any input, any x, and I can have any y, any output for this function. Let's do one more together, and then you guys are going to do number 9 and 10 by yourself. I'm going to give you the solutions to those. So number 8, this one's kind of funky. It's not a line, it's not a U, this is like double U's. All right, so let's do domains. So domains are x's. So I need the furthest left point. Well, that's this guy right here. So I'm going to project him onto the x-axis. My furthest right point is this open circle. I'm going to project him on the x-axis. And all of my graph is sitting here in between. Well, that's not too bad. So we got 1, 2, 3, 4, 5. So the lowest value is negative 5. He's a solid circle, so that's equal to, less than or equal to. All of my x's are in the middle. That's that blue shaded part. And then my highest value is 6. And he's an open circle, so he's going to be less than. And that's it for the domain. So I have all the values between negative 5 and 6, like 0.2, 1.7. All of those are possible x values. Let's talk range. Range is the y's. You do not always use these points. This is not the lowest y value because if I kind of look, I have stuff underneath. This little u is underneath that point. So the lowest point is actually this little curve right there. That's my lowest point. So I'm going to project that guy onto the y-axis, and because he's a solid line, he'll be a solid circle. Now the highest point, kind of similar, it's not this guy. My highest point is this little hump right here. So you've got to be careful. You won't always use the points. The points are nice, but you won't always use them. This is my highest point. So I'm going to project that guy onto the y-axis. And again, solid line, solid circle. And I'm going to shade everything in between because that's where my graph is between those 2 points. So if we look at this, this will be negative 6, and it's a solid, so it's equal to, less than or equal to, and then a y because we're talking about range. And then my highest value is at 2, and it's also solid. And so there's the range. So my y values can be anywhere between negative 5 and 6. Sorry, my x values can be anywhere between negative 5 and 6, and my y values can be between negative 6 and 2. So use what we've learned, try example 9 and 10 on your own, and I will give you the solutions to those. So pause the video, try these two out on your own. Check your solutions and see how you did.